Hello, my name is John Cranner. I'm a semi-retired structural engineer here in Abergavenny, and I've been a STEM ambassador since Christmas of last year. And since then, I've done a number of school visits to talk about my job and how the maths and all the science that they learn at school can be used in a job. And I've also, since that time, have been following a stonemason who works at Lincoln Cathedral, known as a Ginger Mason. Her name is Rachel Ragg. And I've always been interested in her work and how she does a very hands-on, tactile job, but also still needs to use mathematics in the job. And this morning she showed how to work out the radius of a circle when you've only got part of the arc to work on. Or part of the circle, an arc to work on, as she did when she was measuring part of a Norman arch in the cathedral. And she used a formula there, which I've actually not come across or used before, haven't needed to. But then I thought about how I could do a video like this to show how actually that equation comes about. Because although my work is, and that's what I tell students when I go, maths is a very important subject, okay, and so design work. I also tell them, because I did A levels and I did an engineering degree at university. You don't necessarily need to go in that route to do something that's she's a stonemason, so I would call it a technological job. She has to know the material that she's working with, how hard or soft it is and all these other things. And so I do try and tell the students that it's just as important to do a manual job such as that as being a design engineer. So what I'll do is I'll just go through what she did in her video, and I'll give a link to it as well. It's a fairly short video. Show how I got it, because behind me I've got this curved window that I put in about 3 years ago now, just after COVID. How you can work out because it's a quarter circle, so you can work out the radius of it from the arc, that's just part of the circle. And then I'll go through the mathematics of how the formula that Rachel used can be derived. Right, so here we have a long level, which is basically, it's just used as a good rigid straight edge. It's a no length, so it's 48 foot long, and I've measured the middle bit, just as Rachel did. So that's 2 foot in the middle, which is 610 millimeters. So all you do is place it from one point to the other. Hopefully you can see that on the video. So we've got the left point right in there, and then go up to the middle point and take the distance from the circle that you hit to the edge of the level, and that's 273 millimeters. Now, the maths involved in this is not much more complicated than really using Pythagoras' theorem of a right-angled triangle, which is, if you've got a right-angled triangle like that, then sides A, B, and the hypotenuse being C, then C squared is equal to A squared plus B squared. So that's the square of the side and the hypotenuse is equal to sum of the squares of the other two sides. Right, so if we've got our circle, part circle there, and we've taken our edge across there, that's it in the middle there. So we have the known half of the length, which is going to be our distance A, and then we've got the distance from the edge up to the circle, which is B there. So how do we use those two to find out what the radius is? So if we just draw the line, so going down from the radius there, and if I draw a line going up to the middle there, now what I've done there is form the right angled triangle, which is there. So I've got that side as being A there, this is R, and this length here from that point to the point where I measured it is the radius minus B. So using Pythagoras' theorem, what we do is we say that r squared, so we're just using that formula there, Pythagoras theorem, is equal to r minus b squared, which is this length here, plus a squared, which is that length there. So r squared, and then we just expand that squared, that bracket there, so we get r squared, we get minus 2rb, and then we get plus b squared, because minus b times minus b is plus b squared plus a squared. Now, when I was first doing this formula, I thought, oh no, I'm getting r squares involved. But fortunately, what happens is that they just cancel out. So the r squared on each side cancels out there. We take this expression, the minus 2rb, over to the other side. When I was learnt to rearrange formula, you just say, we'll take it to the other side and we'll just swap the sign. So if it's minus there, it'll be plus there. If it's plus there, it'll be minus on the other side. So that goes over there. On the left-hand side, it becomes 2rb equals, and we just swap those round. Is a squared plus b squared. And then we just take the 2r over there. And again, if it's doing multiplying on the left-hand side, it's going to be doing dividing on the right-hand side. So r equals a squared plus b squared all over 2b, which is exactly the formula that Rachel got. Now, the measurements that I took was that b equaled, I wrote it down, oh yes, 273 millimeters. So b equals 273 millimeters, and a, which is 2 foot, oops, that's 610 millimeters. So put that into the formula over here. So r is equal to 610 squared plus 273 squared, all divided by 2 times 273. So if I go, and I hope we can see this, so 610 squared plus 273 squared equals that. So I'm going to dividing the answer by 2 and dividing it by 273 equals 818 millimeters. So that is the radius of the circle.